All right, hey guys. So today on Math with Miss Lastly, that's what I'm calling these. Anyways, today we're going to be looking at complex fractions and complex expressions. So we're going to figure out what is a complex fraction, what is the difference between a complex fraction and a complex expression, and then we're going to go through steps for simplifying these pieces, and then we're going to do some practice. That's our day for today. I will try and keep it short and sweet. So just follow along with your guided notes, fill it in, and then do the practice problems. All right, here we go. All right, so here is our guided notes page that we have in our notebook. All right, so we are on day number 5, notes on complex fractions. We should all be in the same spot, right? Okay. So let me move my little face around. There we go. All right. So first off, complex fraction. So a complex fraction is simply a fraction that is inside of another fraction. All right. So complex fraction, a fraction inside another fraction. All right, so a fraction inside of another fraction. All right, so if you look at the example we have here, we have 1/3 over 1/4. All right, so it looks pretty scary, but really remember, the main thing to remember is that this is just division. All right, we can simply rewrite this nasty looking fraction inside of a fraction as 1/3. Oh, I don't know what that's all about. 1/3 divided by 1/4. And now it's just a division of fractions problem, which we've already talked about how to handle. So you would say, okay, well, 1/3, I'm going to keep the 1/3, I'm going to flip the 1/4, so it's 4 over 1, and then I'm going to change that division sign to multiplication, and then I'm going to multiply straight across. So 4/3. All right, that is the simplified version of this complex fraction. All right, so that's the concept. So really we're just doing division. It just looks a little different. Now, when we get to complex expressions, which is that next piece, there is a slight difference, right? So what you'll notice is not only do we have variables in here, but we also have multiple terms in both our numerator and denominator. It doesn't always have to be both, but generally if you're dealing with a complex rational expression, you're going to have multiple terms in either the numerator or the denominator or both, like this example. All right, so the difference between just a complex fraction and a complex expression is the multiple terms piece. All right, so this is multiple, I think it's because I'm charging. There we go. It's making the pen do weird stuff. All right, so multiple rational terms divided by other rational terms. I went off the page. There we go, rational terms. All right, so you have more than one term in your numerator and or more than one term in your denominator. And just a reminder, by term, we mean pieces that are being either added or subtracted to each other. All right, so in this example that we have right here, 1/3 would be a term, and then 2 over 3x would be another term. All right, so we are going to handle this essentially the same way. So we're going to start by separating this out into something divided by something else, just like we did with the fraction. All right, and so what's really important to do is to identify what the top piece is and what the bottom piece is. So what is the numerator of the whole fraction and what is the denominator of the whole fraction? So for us, those top fractions, that's going to be our numerator, and then down here, the 1 over x minus 3/2 is going to be our denominator. So now we rewrite it. And I'm using brackets just so I keep these pieces together because they do go together. So that's my whole numerator divided by the whole denominator. Now, one mistake students like to make here is they like to try and do keep, change, flip now, but you can't do that. So we can't just flip the fractions in the second parentheses. It doesn't work that way. We have to do something first. This is our denominator. All right, so before we can do the keep, change, flip thing, we actually do need to combine all of the terms of our numerator and combine the terms of our denominator. So we need to actually add these together, and we want to actually add these together. So just like any fractions, if you want to add fractions together, you need to create a common denominator. So for the first one, my least common denominator is going to be 3x, which means I just need to multiply this first fraction by x over x so that I have the 3x on the bottom. My second fraction over here, my least common denominator, is going to be 2 times x. So that means I need to multiply my first fraction by 2 top and bottom, and my second fraction by x on the top and the bottom. All right, so moving right along, I'm going to go ahead and combine those. So my numerator now becomes 1 times x, so x plus 2 all over 3x divided by 2 times 1, so 2 minus 3 times x, 3x, all over 2 times x. All right, so now you've noticed that I have one full piece in my numerator and one full piece in my denominator. Remember, this is the numerator piece, this is the denominator piece. All right, now that I have them combined into one piece, I can now do the keep, change, flip thing. All right, so I'm going to keep the top exactly as is, so, or the first piece, so x plus 2 over 3x. I'm going to flip that original denominator part, so that's going to be 2x over 2 minus x, 2 minus 3x, whoa, forgot the 3, 2 minus 3x, and I'm going to change that division sign to multiplication. All right, so at this stage, this is now just a normal multiplying problem, so we multiply straight across. So we have 2x parentheses x plus 2 on the top, and then on the bottom we have 3x parentheses 2 minus 3x. All right, and at this point we want to simplify anything that can be simplified, so my x's can go ahead and cancel out, leaving me with just 2 parentheses x plus 2 over 3 2 minus 3x. And if you could simplify anything more, then you would, but we can't, so that's where we're going to leave it. All right, so let's just scroll over that way a little bit. There you go. You can do the whole thing. All right, so there's our final answer for that. Not the prettiest thing that I'm sure you've ever seen, but it is the correct answer. All right, so what we're going to do now is we're going to write down the steps of what we just did. So that was the process. Now we're just going to write down our steps. And remember, a lot of these steps are very similar to the steps we've already done with simplifying, multiplying and dividing, and adding and subtracting. Essentially, what this is having us do is just combine all of those techniques, adding and subtracting, multiplying and dividing, and simplifying all into one problem. So it's like the mega problem. All right, so step number 1 is to identify your numerator and denominator. All right, so identify numerator and denominator, and then rewrite it using that division sign. All right, and so then rewrite as numerator divided by denominator. All right, so there's step number 1. All right, so the very first thing that we did was we looked, we said, okay, this chunk was the numerator, this chunk was the denominator, and then we rewrote it numerator divided by denominator. That's step 1. All right, step number 2 is to find your least common denominator. All right, so find least common denominator for both numerator and denominator, and combine the terms. And combine. All right, so that next step, right, was we found our least common denominator. So this would be what's in purple up there, right? So we found our least common denominator for both the numerator and the denominator, and then we combined, right? So we made it into one term. All right, step 3 is going to be to keep, change, flip, right? So step number 3 is keep, flip, change, or keep, change, flip, right? So that's the applying the division property. Step number 4, multiply across. All right, step number 5. Now we didn't do this because I didn't even think about it, but you should do this. Step number 5, identify your restrictions. All right, so identify, right, any restrictions, right? Just remember, as a reminder, right, you denominator cannot equal 0, right? You always want to do that before you simplify. Ooh, I lied. You want to do that before. We gotta slide down. Because we want to do it before we flip, because it makes it a little bit easier. So I'm moving this up to step number 3. Sorry, I know you guys are not on a digital situation, but I'm not re-recording the video. So just draw an arrow. Or like renumber the steps. You want to check for restrictions before you do the keep, change, flip thing, because you want to make sure you have the right denominator. So you actually want to check for your restrictions first before you flip, right? Because then your denominator changes, so you want to do it first. All right, next up, and last but not least then, is to simplify. All right, so identify numerator and denominator, and then rewrite it as numerator divided by denominator. Find your least common denominator for both kind of chunks, and then you want to combine those fractions. Identify your restrictions. So remember, we're not allowed to divide by 0. So for this one, if we want to go back up and do that, because I did forget, all right, our restrictions we have right here, 3x. We know this cannot equal 0, so that means x cannot equal 0. And then our other denominator, which was 2x, also cannot equal 0, which is x cannot equal 0. All right, so our restriction for this one is just that x cannot equal 0. All right, so I did that before I keep, changed, flip, all right, or keep, flip, change, however you want to do it, all right? So that's the proper order, all right? And then we multiplied and we simplified. So let's do 2 practice problems. One is just a complex fraction. The other one is more of a complex rational expression. So we have variables in that number 2. All right, so here we go. First off, identify numerator and denominator. So numerator, denominator, rewrite it. So I'm going to use the brackets just so I remember what piece is what. So 25 over 4 plus 3 halves. That's the numerator, divided by 1/5 minus 4 over 25. That's the denominator. All right, next up is figuring out my least common denominator and then combining. Ooh, I'm a little bit... There we go. All right, so least common denominator for the first one is going to be 4. Both 2 and 4 can multiply into 4, so that's going to be that one. And then for this one, least common denominator would be 25. All right, so for the first fraction, I need to multiply top and bottom of the second fraction by 2 to get that 4 on the bottom. And for my second piece, that denominator part, I need to multiply the first piece of that section by 5 on top and bottom to get the 25 in my denominator. All right, so next up, we're going to go ahead and combine our stuff, right? So we've got 25 plus 6 all over 4 divided by 5 minus 4 all over 25. All right, so we can now simplify this, right, because we know what 25 plus 6 is, hopefully. All right, so there is 31 over 4 divided by 5 minus 4, so that's going to be 1 over 25. All right, so now we are at the keep, flip, change situation. So 31 over 4, and this is 25 over 1, and we are multiplying. So this becomes 31 times 25 all over 4 times 1, which is 4. Now I don't have a calculator, so I don't know what 31 times 25 is. Hopefully you have a calculator. I'm just going to leave it like this because I don't know what that is, and I don't have a calculator. Cool, moving on to the second one. So we're going to run through the same thing. We've got our numerator and our denominator. Now we're going to rewrite this. So numerator is 1 over 3a minus 1 over 3b divided by a over b minus b over a. That's the denominator. All right, next up is to find my least common denominator. It's going to be 3 times a times b for this first one. So my first fraction needs to get multiplied by b. Second fraction gets multiplied by a on top and bottom. So then my denominators are both 3ab, so I can combine. Second fraction, least common denominator, is going to be a times b. So my first fraction needs to get multiplied by a. Second fraction needs to get multiplied by b. All right, rewriting this, I now have b minus a over 3ab divided by a times a, so a squared minus b squared all over a times b. All right, so keep, change, flip. So keep, change, oops, keep, flip, change. Okay, now as I do this, I am also going to be figuring out if I can factor anything. So because I'm kind of thinking in my mind that I'm going to be doing some kind of simplifying, right? You can save this till later if you want. I'm going to kind of do it right now because I see some things that do need to be factored, and they can factor pretty quickly. So first off is b minus a. All right. I'm going to rewrite this by factoring out a -1 so that a comes first and is positive. So -1, and then that changes this to a minus b. The reason why I did that and I wanted a to come first with the minus in between is because I see that I have a squared minus b squared. That's the difference of perfect squares, and so that's also going to factor. And since that term has the a out front, I want the a minus b or b minus a to have the a out front as well, because then we're going to get some stuff that simplifies. All right, so this is all over 3a times b. All right, so like I said, the a squared minus b squared is going to factor. All right, but first I'm going to move the a times b to the top because I am flipping. All right, a squared minus b squared factors to a minus b times a plus b. That's the difference of perfect squares. That's definitely one you need to know. All right, and I'm going to change that division sign to multiplication. All right, and from this point, I am going to be lazy, and I'm now just going to multiply across. So I just extended my thingy. This is now all multiplication, right? So we're just multiplying straight across. All right, at this stage, I'm going to go ahead and simplify. So I can simplify out the a times b on the top and the bottom, and I can simplify out the a minus b factor on both the top and the bottom, leaving me with a final answer of -1 over 3 times a plus b. There we go. All right, I hope that was helpful. Hopefully you are now able to go and finish up your classwork. If you have any questions, write them down, and I'll be sure to go over them when I come back from Thanksgiving break. All right, guys, bye. Have a good day.